In order to best understand the Connex framing system and the modular kit of structural steel parts, it's helpful to look back at the origins of modular construction kits, starting with the very smallest. In 1911, as Alfred Carlton Gilbert rode the train from New Haven to New York, he watched as steel girders were being erected as part of the rail line modernization along the route. This modern steel construction he saw inspired him to create the very first toy erector set. The erector set consisted of a selection of metal beams with regular holes for assembly using nuts and bolts, with the ability to build a model, then take it apart and build something else, over and over again. The toy was known as the Gilbert Erector, the toy-like structural steel. Since then, many types of erector sets have come and gone as the hobby continues to capture the imaginations of enthusiasts young and old. The idea was fairly simple. Readily available, mass-produced parts made in different places at different times that snap together with precision without fail. Each kit would have enough component parts and accessories to make many different structures. With the right combination of parts, the possibilities seem only limited by the imagination of the user and the size of the kit of parts available. Now, while there are a variety of these scale version hobby sets that can be purchased around the world, very few full-scale erector sets have ever achieved such widespread use other than scaffolding. And while scaffolding can be used for many different applications, there are so many more applications where scaffolding simply cannot be used. Connex is the full-scale erector set that goes together like scaffolding, yet has the strength and stiffness to frame all sorts of structures. The Connex kit of parts is made from a set of beams and columns of variable length with a choice of beam end connection types. Any structural geometry that can be defined as orthogonal lines connecting at a point in space can be assembled from Connex components selected from the kit. The beams are standard wide flange sections, and the columns are square, concrete-filled, hollow steel sections. Beams come with either moment connections at both ends, a moment connection at one end with a simple shear connection at the other end, or simple shear connections at both ends. If the beam end is a moment connection, a Connex connector is added to that end of the beam. If the beam end is pinned, then it is cut and drilled to a standard hole pattern for a single line of bolts. The columns have either a moment-based connection or a simple base connection, and along the length of the column where beams will be connected, there are either moment or shear connectors attached to the column face. The machined connectors lock into place with ease, allowing light crews to rapidly frame the space using the kit of parts. The interlocking plates provide vertical and lateral support to the frame during erection, allowing the bolts to be installed later from a safe working surface. The Connex kit of parts doesn't come in a box like an erector set. The kit is really a made-to-order digital kit created in a BIM environment such as Tekla, with beams and columns of any length required. The parts are then made from the digital model using automated cut and drill lines and robotic welding before being sorted and delivered to the site for erection. Some people might say that the AISC Steel Manual is also a kit of parts that can be made to order and delivered to the site. In many ways, they are correct. All the same members can be used, and there are 4 or 5 varieties of every type of connection that can be designed by any engineer to connect the beams and columns. A digital BIM model can then be used to fabricate and deliver the frame to the site. However, the scope of possible connection types and sizes is almost limitless, and the permissible steel fabrication tolerances make mass production, global deployment, and predictable precision impractical. The state of the structural steel fabrication industry has advanced little in the last 100 years. Each structure is a custom-ordered building designed from scratch, just like early cars were made before Henry Ford revolutionized production. The precision and efficiency that Connex brings at every stage of production, from procurement to fabrication and erection, are only possible because the set of connection types has been reduced to a manageable subset of repeatable precision manufactured parts. In a way, history has come full circle. The story began around 100 years ago with one man's dream of a toy just like structural steel. Today, another vision is unfolding, that of structural steel framing that is just like a toy. Now, there are major differences between all the scale hobby erector sets that are out there and a full-scale structural steel kit of parts. The structures built with the hobby sets are only limited by the imagination of the user. However, the full-size structure has to be designed to support loading due to gravity, wind, seismic, and thermal effects because their effects can have grave consequences. In order to preserve life and property, frames, members, and connections must have adequate strength and stiffness to resist the maximum member forces without exceeding their respective available strengths. The frame members must also have adequate stiffness in order to limit deflection to acceptable levels that don't impair the function of the structure. So how does a structural engineer determine whether the Connex frame is adequate for the intended purpose? Put simply, they must first determine the maximum forces on each member and connection in the frame, and then confirm that the available strength in each case is greater than the demand. Secondly, they must determine the maximum deflections and frame deflections and determine whether they are less than accepted limits. The structural engineer typically builds a mathematical model of the structure using finite element software and applies loading in accordance with the governing codes to determine the resulting member forces and frame deflections. The members and connections are then designed following applicable specifications, provisions, and design guides. These basic steps involved in the design process are going to be the same for any structure. So the real question that needs to be answered is what is different about the design procedure of a frame using Connex components when compared to a frame built using connections taken from AISC's selection of connections and members. Before delving into the similarities and differences in the structural design procedures, an introduction to the three unique systems offered by ConnexTech should prove to be very useful. The three systems are Connex R200, Connex L400, and Connex L300. For each of the three systems, we will examine the kit of parts that comprise the frame and then discuss the basic load resisting mechanisms. We'll also cover code compliance testing and common applications for all three systems. Once we've established a familiarity with all three systems, then we can delve deeper into the actual calculations of the various components unique to each one. Now, since Connex R200 was our first connection, we'll start there and then move on to the other two systems.